Practice set 7, problems 4 and 5, found on page 28. Determine the mean and standard deviation for each of the following normal distributions. When you have something that's normally distributed and it's graphed, the middle value will always be the mean. So for the mean in A, the value that is on that line of symmetry, so that both sides are reflections of one another, has a value of 9. No calculation is needed. Furthermore, each of these lines indicates one more standard deviation, in this case above the mean, and here one more standard deviation below the mean. In the previous problem, we were looking at determining where 68% of the data, 95, 99.7, what those boundaries were. Those boundaries are found by taking the mean and adding a standard deviation or subtracting a standard deviation and multiples of it to go further out. So if I'm looking for the boundaries of 68%, I would take the mean, add a standard deviation for the upper boundary, and if you look here, what was added to 9 to give 11, there was 2. And if you look at every value next to one another, each one has an increasing value of 2. That's increasing values of standard deviations. Likewise, on the lower side, if I'm looking for the lower boundary of 68% of the values, I would take the mean minus a standard deviation to give me that boundary. Well, the difference between 9 and 7 is 2. Again, that value of 2 is cropping up. 7 and 5 differ by 2, 5 and 3 differ by 2. 3 standard deviations below, 3 standard deviations above are the boundaries for 99.7% of the data. So these vertical lines are showing us the boundaries for 95, 68, 99.7. In any order, every one of those values differs by 2. Long story short, the standard deviation, represented with this lowercase sigma, is 2. In the next graph, the mean is in the middle. The middle value is here given as 20. Standard deviation is the difference between these upper boundaries or the lower boundaries for the 68%, the 95, or the 99.7. And if you look at adjacent numbers, every adjacent number is differing by 3. So the standard deviation for this problem is 3. The last one, what's the mean? The mean is in the middle. No calculation required. Likewise, standard deviation. This is 1 standard deviation above. This is 1 standard deviation below. How do the numbers differ? They differ by 1. Those boundaries between 70 and 72 would represent 68% of the data. In number 5, A asks us 68% of the data in distribution B is found between the lower boundary and the upper boundary of what? So we're in graph B. 68% is 1 standard deviation above and below, and they're asking us for those boundaries. So to answer this, the lower boundary would be 17 and the upper boundary is going to be 23. B states 95% of the data in distribution A is found between the lower boundary and the upper boundary of what? So here we're in graph A. 95% is always 2 standard deviations above and below. So 95% of whatever this is going to fall between a low of 5 and a high of 13. Given it's normally distributed. So to answer that, we'll have a lower boundary of 5 and an upper boundary of 13. C asks 99% of the data in distribution C is found between what boundaries? 99.7 is equated with 3 standard deviations above and below. So on our C distribution, we'll go up 3 and down 3 from the mean. What are those boundary values where virtually all of the data is going to fall? The numbers there give us a lower boundary of 68 and an upper boundary of 74.